Good day, everyone. In this presentation, we are dealing with polynomial graphs. In this particular lesson, we're going to discuss and analyze graphs a little bit further. Alright, to be successful, we have to understand the law of exponents, and we have to know that x has a coefficient and exponent of 1. Your Eureka lessons for this particular lesson are going to be used in lesson 14 and 15. If we have time, we could touch over lesson 13. Now, keep in mind, because we have did most of these lessons already without the Eureka book, it's the reason why we don't go from lesson to lesson, because we already did many of these lessons throughout the time that we started school. But I may say go back to lesson 2 or something like that just to review for what was taught. Alright, announcements. Y'all, supplies are dwindling. I don't have no pencils and all like that for y'all. Please be aware of academic dishonesty because it can make things harder. I already spoke to you guys about it, and yes, so far your quiz that you will have would not be open notes. I'd see what you could do for your memory. Good luck. I hope you are really putting the effort to understand. If you are absent, you are still responsible both for the work as you are here. If you have an excuse, you must immediately turn it in to me. Otherwise, I can't give you the makeup work. Just for a reminder, if you want paperwork, you want to ask me for it. Be aware, I know you guys don't like this at all, but you're going to get the stuff wrong before you get it right. It takes practice and hard work. That's the reason why I gave out so much to do. So if you really put in the effort to trying to get it versus just doing it, that's going to help you out to decide you're going to pass or fail. Mistakes allow thinking to happen. You're going to make mistakes, but you have to be okay with them and expectations of wanting to grow and to become better. I'm trying to change the mindset, everyone. Alright. Teachers not going to spend too much time on the board. You guys going to have to try. You guys going to have to get to the board more often. Alright. Solving equations by methods. In our previous class, we already did the lesson 11 opening exercise. So in this unique factoring cases, in the previous video, I talked to you guys already about the quadratic formula, which you're going to use when things are not factorable. Like in this trinomial, it's not factorable, so you figure this out on your own. So I'm going to show you all of this, but I'm just going to move on right quick. So all I'm showing you is just plugging in stuff. Plug in, apply the rules of negative square roots, and that's just that. If you misunderstood how I got to all this, please go back to the last video that I posted. And of course, we learn how to check our work. And of course, this is another example. Again, I'm not going over step by step over something that was shown to you. In class, I may do it, but in this presentation, I would not, because you have some examples of that already, and you've seen it in your homework too. Alright, this is an example of solving This what you guys know how to do well. And when we put this in decimals, this is what we got. And again, I'm not really explaining how to do any of this. Alright, however, I am going to talk about this. Anytime a graph touches the x-axis, which I already talked about this too in that last video, so I'm not talking about that either. So go back to the previous video, how I did all of this. Go back to the previous video for that. So again, if you are struggling with this, all the stuff that I have skipped so far, just work it out yourself and see do you match my work. So again, I'm moving on. All right. So now getting into the meat of the lesson. This is the lesson for today. All this other stuff that I just flashed through, I didn't spend no time on because covered in the previous video. Graphing polynomials. It's an easy lesson, y'all. I promise you, it's not hard. So, when the graph touches the x-axis, well, in this particular graph, this is symmetry. This is symmetric around the y-axis. So therefore, this is an even function. Even functions, simply as the case says, you have a function with only even exponents. You see all those even numbers 2, 4, 6? They're going to look like this always. They're going to be symmetric. Meaning that if I was to fold this line up in half, it'd be a perfect symmetry. Alright? I'm just drawing my lines just to show you symmetry. Alright, now this in particular is an odd function. Because if you have an odd exponent, it's all gonna reflect through the origin. It's going to be reflective through the origin. Reflected through the origin. Reflected through the origin. Alright? And again, it's odd because you're going to have to deal with functions with 3, 5, 7, anything with an odd number of exponents. It's going to tell you even or odd. Well, odd number of functions is odd. So because it's odd, it's symmetric around the origin. So you have a graph that looks like this. That is neither symmetric on the x or on the y-axis. And because of that, it's neither even or odd because it's not symmetric anywhere. Alright? It's not symmetric through here, or it's not symmetric through the origin. So, because of that, it's neither. And when you have a function that consists of even plus an odd number, that's neither. Neither. So is the first function even? It's who's even, who's odd, who's neither. So the first one is even because it's symmetric around the y-axis. The middle one is odd because it's symmetric through the origin. The last one is not symmetric at all, so it's neither. Graphing polynomials and identifying solutions of graphs. Like I said, this lesson is not hard at all. So here, yes, I know it's a mess, isn't it? Well, we know it's not symmetric, so therefore it's not even or odd. However, when you look at x plus 3, the factor x plus 3, and of course, we know when we see factors, we set them to 0, and when we solve for x, we get x equals -3. But we just learned that this right here is my solution, but also my x-intercept, and that is going to be right here at -3. All right, and that's what I did for the first one. All right, so let me do the second one. The second one has x minus 2 squared. This exponent right here tells you that this factor repeats each other. X minus 2, x minus 2. It repeats twice. However, because it repeats twice, I just only had to solve it once because the solution is going to repeat itself. X minus 2 equals 0. I know when I solve for x equals 2, but we learned that my solution, which is another word for 0, and we know that my x-intercept is going to be 2, 0. And again, well, before I get to that, this 2 right here is my x-intercept. But you notice that 2, it bounces versus going through. So when that happens, you're going to have a thing called a multiplicity. When it's a multiplicity, it only bounces, does not cross. So the last one, although I have shown you the answers already of that one, but let me explain it right quick. So the last one is x plus 1 squared. And I do apologize about this, but I'm doing this by hand. Again, my multiplicity meaning that this repeats twice, so it's going to be x plus 1 and x plus 1. And because it repeats, I just got to solve it once. And when I solve it once, again, I do apologize about this handwriting. It's going to be x equals -1. And because that's the case, -1's right here. Oh, it didn't have a 2. I'm sorry, that has a 3. Alright, yeah. I see why people got confused on that. That's a multiplicity of 3. So when you have a multiplicity of 3, it's going to look just like this guy right here. But I'm going to explain the details of multiplicities of 1, 2, and 3. Alright, so here we get our x-intercept to be -1. So again, anytime that you have a factor that repeats has a multiplicity. Alright, multiplicity means repeating factors. So let's go through these. So here, a single 0, that just means it could be like x plus 3 with not much of a multiplicity. It would not be a multiplicity, but some people like to call it a multiplicity. To me, multiplicity means repeats. So if I got nothing to repeat, I don't have a multiplicity, but just to be safe, go ahead and call it 1. But in my classroom, if you said that x plus 3 does not have multiplicity, I'd be cool with that. Here, when it says a multiplicity of 2, so all I'm saying is x plus 3 squared, because that's the multiplicity of 2. That just means that x plus 3 is going to be x plus 3 and x plus 3. Now here, this is a multiplicity of 3. Just pay attention how the graph looks. So that just means x plus 3, x plus 3, and x plus 3. Alright? So that's what I mean by multiplicity. How many times does it repeat? And what's going to tell you about your multiplicity is going to be your number outside of the factor. So if you want to, pause the video or rewind this part and just observe how the graph looks when you have no or one multiplicity, when you have multiplicity of 2, meaning that it repeats twice, or when you have a multiplicity of 3, meaning that the factor repeats 3 times. So pause the video, take notes of it. Alright, so here, this is neither. It's not symmetric, so it's neither even or odd. So here, let's look for my x-intercepts. So here, I have an x-intercept of 3, or negative 3, or you could write it as negative 3, comma 0. You could do that. X equals negative 1, writing it as negative 1, comma 0. And then you have x equals 4, with 4, comma 0. Those are my zeros and my x-intercept is neither even or odd. Now, in the classroom, I added one more thing, which I'll probably cover before you guys take quiz. But I'm not going to cover in this video because I need for you to know multiplicity types and x-intercepts. So let's look at the possible multiplicity of this. X minus 3 look like a multiplicity of 2 because that's how the graph looks. Now, we want to assume that that's the case because when the graph bounces like that, it has a multiplicity of 2. Now here, you see how the graph just cuts through for x minus 1? The multiplicity of that is going to be just 1. Because it just cuts through. You see how 4 just bounces like that? I mean, it has like a little sharp curve in the bounce. That looks like a multiplicity of 3. Now, if you got lost in this, just go back and rewind. But for those who understood, the stuff I highlight in blue is the multiplicity. So that means if I have to create an equation that has the 0 of negative 3 and the multiplicity, that means it's going to be x plus 3 with a multiplicity of 2. And then x minus 1, or it's going to be x plus 1, because when I solve this, x plus 1 is going to be negative 1 for the solution. And with the 1 multiplicity, or leave this blank because that's understood to be 1. But I personally say there's no multiplicity because multiplicity means to have repeated factors. This x plus 4, well, it's going to be x minus 4. When we solve it, it's going to be x plus 4 with a multiplicity of 3. Alright? So, when you are given your x-intercepts or zeros, you may be asked to create the equation of this graph by the zeros. So you got to create the graph, create the equation like we did here, or the factor x plus 3 with the multiplicity of 2. Again, you get lost on this, please rewind this part. Erasing everything. So, everything I have said, those are my answers. Alright, It is your turn. You try this one on your own. I need to know the zeros, the x-intercept, which we know to be the same, and the multiplicity. It is so hard to do this on the keypad, on the mouse. So those are the three things I want you to do. Alright, so in class today, I didn't talk about graph behavior, but I will in this video right quick. So the graph, because you have an arrow, it is coming from the negative infinity side. So anything coming from the negative infinity side usually always decrease. Then it increase, and then decrease, and then increase, but increase to positive infinity. Alright? If I use the word degree, I'm saying your largest exponent you have in your function. Like for example, here you are given a function. The degree of this is going to be just 4, because 4 is my biggest degree. Alright. But your Eureka book wants you to do something different. So be advised that this is the part that Eureka does something completely different. What I just showed you is something different. Eureka wants you to add the number of x's you have, but I'm going to explain that in class when we work from my Eureka book. So I want you, well, let me do this one, and I'll be done. So here, you want you to state your zeros and your multiplicities. So here, by looking at my graph, I know that my zeros or my x-intercepts, you could write it in any way you choose. You could write it as zero, one, and 3. And those multiplicities that you have is going to be right here and right here. So you can say your multiplicities to be 2 and 3. Your degrees in Eureka, they want you to add up the number of x's you have. In your Eureka book, they want you to add. So there's 2 x's right. Well, this is repeating, so I got 2 x's already. 3, I have 6 of them. because again, the multiplicity means repeat. Alright, y'all. If you need further assistance, we will discuss this a little bit further.